Morning friends. Today we will see how to find the Y-bus matrix by direct inspection method. So Y-bus is nothing but bus admittance matrix. We can obtain this Y-bus matrix by direct inspection method in a easy way, just if you have the knowledge on KCL. KCL means Kirchhoff's current law. Now, for finding Y-bus matrix, or to know how to find the Y-bus matrix, I just took a 3-bus system, 3-bus power system. It consists of 3 buses, 1, 2 and 3. And to the 3 buses, we have the generators that are connected as well as some loads. And these are nothing but the transmission lines that are connected in between first bus and second bus, first bus and third bus, similarly from second bus to third bus. So we have in this power system network, I represented some transmission lines, generator as well as the load that are connected at each and every bus. Now we will see how to find the bus admittance matrix. Here I can convert this power system network into this diagram. Here this is nothing but a generator. A generator usually represented with a reactance behind a voltage source. So we can represent a generator like this, and with the help of source transformation technique I can convert this as the parallel combination of a current source and a impedance or reactance. So actually the generator is represented as a series combination of generated voltage as well as the impedance. Now I can replace this with a current source in parallel with the impedance, so that at each and every bus, in place of generator, I can replace that with the current source in parallel with some admittance. And if you see this diagram, at each and every bus we have the current source as well as the admittance that is connected in parallel in between the bus and ground. Similarly, for the second bus also you have a current source I2 and admittance connected in parallel between the bus and ground. And for this also, if you see all these, you can understand how we applied the source transformation technique. And in addition to that, I replaced each and every transmission line, 1 to 2, 2 to 3 and 3 to 1, the 3 transmission lines with their equivalent pi network. So this is the equivalent pi network of a transmission line, this is another equivalent pi network, and this is another equivalent pi network. When I replace all these with this, you can have a comparison between these two diagrams. And now, how to apply KCL? Before applying KCL, I need to convert, for simplicity, I need to convert all the elements as admittances. So I am just replacing the series impedance which is connected in between first bus and second bus as the admittance. So it can be represented as Y12. Similarly, the series impedance which is connected in between 1 and 3 can be determined, and means Y13 is the admittance actually 1 to 3, and it is obtained from the series impedance. If you know the impedance, you can find the admittance easily by taking its reciprocal. Similarly, you have this as the admittance. And if the load is mentioned in the problem, so I can replace this load as well as the generator with some admittances. So this is the equivalent admittance which is equivalent to the parallel combination of the admittances of generator as well as load. Similarly, this is the equivalent value or equivalent impedance of the parallel combination of this load and this generator admittance. Similarly, this admittance. So like that we will have the admittance between bus and ground. And now if you apply KCL at this point, means at each and every bus apply KCL, I am applying KCL at each and every bus. So the incoming currents are the injected currents at each and every bus. At this bus, the injected current is I1, and at this bus the injected current is I2, and at this bus the injected current is I3. So these are the injected currents. Now based upon these injected currents, with the help of KCL we can write the equations. So the current which is moving from 1 to 2 has can be represented with V1 minus V2 into Y12. Voltage into admittance is nothing but current, we know that already. And another current is coming from 1 to 3, so V1 minus V3 into Y13. You have the third current which is from ground to which is from bus to ground, so that it is V1 minus 0. The voltage of ground is taken as 0, so the voltage difference into admittance gives us the current in each and every case. Similarly, we got the second equation for the second bus. If you observe, it is V2 minus V1 into Y12, one current, V2 minus V3 into Y23, and V2 minus 0 into Y20. Y20 is nothing but the equivalent impedance connected in between each bus. Y20 is the equivalent impedance connected in between each bus and the ground. So between this bus and ground, it can be taken as Y10 as well as Y20 as well as Y30. These are the equivalent impedances connected in between the bus and ground. Now we will see how to modify this equation and these equations and obtain Y bus matrix using direct inspection method. So we'll see how to do that. So we need to do some mathematics in order to obtain this Y bus matrix. So we just need to write these three equations which I have written here. We need to write these three equations in much more comfortable form in order to understand easily. So I am just separating V1 terms, V2 terms and V3 terms. So for V1 we have the coefficients of Y12 plus Y13 plus Y10. Hence I can write this as Y12 plus Y13 plus Y10 into V1. Similarly, for V2 I can have only one coefficient which is minus Y12. So I can write this as minus Y12 into V2. And for V3 we have another only one coefficient which is minus Y13 into V3. So this is the first equation in a modified form. Similarly, I can go for the next equation in a modified form. So this next equation can be written as I2 is equal to, so for V1 you can take this admittance, so I can have minus Y12 into V1 for V1, and for V2 if you consider from this equation it is Y12 plus Y12 plus Y23 plus Y20. So Y12 plus Y23 plus Y20 into V2. Next for V3 you have only one term which is minus Y23 into V3. This is the second equation. Now I can take the third one. So which is I3 is equal to, for V1 the coefficient is minus Y13, so it is minus Y13 into V1. For V2 it is just minus Y23 V2. For V3 you will have Y30 plus Y13 plus Y23 into V3. So I can now have an idea how to identify the coefficients of V1, V2, V3. And now we will see how to obtain the bus admittance matrix, means the parameters of bus admittance matrix, how to obtain. If you consider the bus admittance matrix, the performance equation of bus admittance matrix, I can have like this. So I1, I2, I3, it is actually equal to matrix values y11, y12, y13. As the power system network which I considered is a 3-bus power system, so I can find these values like this: y11, y12, y13, because I have only 3 by 3 matrix as y bus matrix. So y21, y22, y23, y31, y32, y33. This is a y bus matrix and this is a column vector of injected currents. Similarly, you will have a column vector of the voltages V1, V2, V3, where these are the voltages at different buses with respect to reference or with respect to ground. Now, I can take the equation from this matrix so that I will get I1 is equal to, first row with first column, you will have y11 v1 plus y12 v2 plus y13 v3. Similarly, for the second equation, I can get I2 is equal to y21 v1 plus y22 v2 plus y23 v3. Similarly, for I3, y31 v1 plus y32 v2 plus y33 v3. From this performance equation in bus frame of reference, I got these equations. Now I compare these three equations with the above three equations in order to obtain the different parameter values, means the matrix values. Now compare these equations with these equations. Let us assume this as 4th, 5th, 6th. If you see in the equation 1 and 4, we have LHS values as equal, which is I1 and I1. So I can compare first and 4th. Similarly, in equations 2 and 5, from equations 2 and 5, we have LHS values as equal, I2 and I2. So I can compare second equation and fifth equation, and third equation and sixth equation similarly. Now, in place of y11 here we have this expression. So I can have y11 is equal to, by comparing this, I will get y12 plus y13 plus y10. Next, so I can write this with other ink so that it is easy. So y11 is equal to y12 plus y13 plus y10. And another equation, if you compare these two equations, you will get y12. In place of y12 we have minus y12. So minus y12. First I will write all the things, then we will compare easily. So y13, next y21, y21, y22, y23, next y31, y32, y33. So now if you observe, from the fourth and first equation, in place of capital Y13 we have minus Y13. Similarly, by comparing the second equation with the fifth equation, in place of Y21 we have minus Y12. In place of Y22 we have Y12 plus Y23 plus Y20. In place of y23 we have minus y23, and here in this equation, in place of if you compare the third and the sixth equations, you will have in place of y31 you have minus y13, and in place of y32 we have minus y23, and in place of y33 we have y30 plus y13 plus y23. Now we got the equation. Comparison is over. Now we will see, we'll just have a simple analysis with this comparison. If you erase this, you can easily identify the remaining things. So now see here. If you see, capital Y11 is nothing but the element, the diagonal element of Y bus matrix. Similarly, capital Y22 is another diagonal element. Capital Y33 is the third diagonal element. So the diagonal elements can be obtained by just taking the summation of all the admittances that are connected to that particular bus. Means if I want to have a first diagonal element of Y bus matrix, I can go for the actual network, for the given network. In the first bus, I need to know what are all the admittances that are connected at that particular bus, and I need to add all those admittances in order to obtain Y11. Similarly, if I want to get the second diagonal element of Y bus matrix, I need to go for the second bus in the actual network and see what are the admittances that are connected to that second bus. So, and we add this, we will get another diagonal element. Similarly, third diagonal element. So what we understand from this is, if I want to know the diagonal element of a Y bus matrix, I need to know what are the admittances that are connected to that particular bus in the actual network, and we need to add all those admittances in order to obtain the diagonal element. Similarly, if you observe the off diagonal element y12 is minus y12, y13 is minus y13, y21 is minus y12. Like that, if you observe any off diagonal element, it is obtained just by taking the negative value of the actual admittance. If you know the actual admittance that is connected in between the two buses, and if I want to find that off diagonal element, just keep the negative sign. So y13 is minus y13, y21 is minus y21, similarly y23 is minus y23, like that. You just for off diagonal elements, you can keep a negative sign for the given admittances. The one fact is, in order to obtain diagonal elements, you need to add all the admittances that are connected to that particular bus. In order to get off diagonal elements, we need to keep the negative sign for the given actual admittances. And in addition to that, what we need to observe is first row second element. Y12 is first row second element, y2 is second row first element, both are of same value. Similarly, y13 first row third element, third row first element, both are of same value. Next, second row third element, third row second element, both are of same value. If you observe this as at the same values, we can understand that the matrix, the Y bus matrix, is a symmetric matrix. See, for example, I will just represent them like this. Now I will represent them in a matrix. As we have determined all the things, we just represent them in a matrix. So Y bus is equal to, what is the first element? First element is y10 plus y12 plus y13. What is the second element of the matrix? Minus y12. What is the third element of the matrix? Minus y13. Next, second row. For the second row, first element is again minus y12. Second element is y20 plus y12 plus y23. Next, third element of the second row is minus y23, and seventh element means first element of the third row minus y13 minus y23, and here you will get y30 plus y13 plus y23. So now this is the actual matrix. If you clearly observe this matrix and take the transpose of this matrix, transpose means interchanging the rows and columns. If you take the transpose for this matrix, you will get the same matrix. So from this fact we can understand Y bus as a symmetric matrix. So this is the first fact related to Y bus. So bus admittance matrix is a symmetric matrix. This is the first fact which we need to know about the Y bus matrix. And the second fact is there is no guarantee that there is every element, mean in between each pair of buses. In between each pair of buses, there is no guarantee that a transmission line present. Sometimes there is no transmission line between 1 and 3. In that case, you will have this element as 0. Similarly, you will have this element as 0. When you have at least one element as 0 in the matrix, we can call that a matrix as sparse matrix. So Y bus matrix may sometimes be sparse matrix because it contains some of the elements as 0. And the third thing is that for a Y bus matrix of order n by n, for example, if the power system network contains n buses, the Y bus matrix of Y bus order will be n by n. If for a power system network of n bus containing n buses, you will have the Y bus matrix of order n by n. In that case, as this matrix has the nature of symmetricity, means it is a symmetric matrix, this value is same as this value. Similarly, this value is same as this value, and this value is same as this value. Hence, there is no need to store all the elements in the digital computer. So for a Y bus matrix of order n by n, it is just sufficient to store n into n plus 1 by 2 elements in the digital memory. So the memory requirement will be lesser because of this nature of symmetricity. So up to now we have studied how to obtain the Y bus matrix using direct inspection method in a easy way, as well as the nature of Y bus matrix or the features of Y bus matrix. So thank you very much for listening to my class. If you like this class, please share and subscribe my channel.